All right, in this video, we are going to work through problem 4.118 on motor vehicle use. Um, I have written the parts that we have to do down here, and then I am just going to go back to the data so we can actually do this problem here. All right, so for a randomly selected vehicle, describe the events C1V3 and C1NV3 in words. Compute the probability of each of those events. Compute the probability of C1 or V3 using the contingency table. And the F divided by N rule, which is the number of elements in your event divided by the number of things in your sample space. And then compute the probability of C1 or V3 using the general addition rule and your answers from part B. And then finally on part E, construct a joint probability distribution. So, nope, that's not it. Let's see, we want this right here. Okay, so I'm going to go back to where the data is, and here's the data for that problem. All right, so part A is to describe these events in words. So the probability of C1 is the probability that a randomly selected North American vehicle is from the United States. V3 is the probability that a randomly selected North American vehicle is a truck, and C1 and V3 is the event that a randomly selected North American vehicle is a truck from the United States. Okay, so that's what those events are. Next up, we want the probability of C1. All right, so C1 is the probability that the vehicle chosen is from the U.S. Right, so that's going to be this marginal probability. We would take all of the vehicles that were in the U.S. and so there would be not there. All the way back up here. So there would be 209,539 thousands, right? So that is the number of vehicles in the US, and then divide by the total number of vehicles in our sample space, which is 243,094. So that would be the probability of C1. The probability of V3 that a randomly selected vehicle is a truck, a North American vehicle is a truck. So we would have to figure out how many trucks there are, right? So that's given over here in this marginal area, right? So we know there's 87,160 trucks. And then we would divide by the number of vehicles in our sample space. So that would be the probability for a truck. And then finally on this part B, we want to know what's the probability of C1 and V3, right? So that would be the number of trucks there are in the US, right? So that's 75,940,000, right? And then divided by the number of trucks in the sample space, so that's 243,094 thousandths. Okay. And let me see if I can move that over slightly. There we go. Okay, so next up, they want to know what is the probability of C1 or V3, right? So C1 would be all of these here. And for this, I want to draw on this area right here. So let's just do it this way. So we want to find the probability of C1 or V3, right? So anything that's in this column or this row, right, the C1 row or the V1 row is going to figure into that, right? So these numbers, right, these are all in C1, the event C1, and all of this row, right, is all in the event V3, right? So one way that we could calculate the probability of C1 or V3, right, is to just add all of these numbers up and see what we get. All right, so when we do that, we get 129,728 plus 3871 plus 75940 plus 6933 plus 4287. So we get 220,759, right, divided by 243094. I think I did that right. 220,759. Yep, looks good. Okay. So that's the probability. Again, the one thing that you would not want to do on here, right, is to add these two numbers up. Add this marginal number for C1 to the marginal number for V3. That will not give you the correct answer, right? Because that will mean you will have double counted all the US trucks, right? And so you can use that trick I showed you in one of the previous videos where you subtract this back out. But it's almost just as easy to just circle these ones in the table that you know that you want to count and just add those up. Okay. All right, so C1 or V3, now they want us to calculate that same probability using the general addition, or using these values that we found up here and the general addition formula. So if you think back to section 4.3, right, this would be the probability of C1 plus the probability of V3 minus the probability of C1 and V3, right? Remember, we had the generalized addition rule or the specialized addition rule when it came to calculating these out. We would have to ask ourselves if we can use this special addition rule if these events are mutually exclusive. Can they happen at the same time? If you pick a single vehicle from North America, is it possible that it's both from the United States and it's also a truck? Could that happen? And the answer is absolutely, it could happen, right? So these things are not mutually exclusive. The event C1 being a vehicle in the US and V3 being a truck, right, are not mutually exclusive. So you cannot use the specialized addition formula. You have to use the general one. All right, and then we've already calculated these probabilities, right? The probability of C1 is 209,539 over 243094. V3 is 87160 over 243904. And then the probability of C1 and V3 is 75940 over 243094. Okay. And so then what you would do is just combine those fractions together, right? They all have a common denominator. So 243094. And then you can just combine the numerators, right? So that would be 209,539 plus 87160 minus 75940. So 220759 when you do that. All right, and you can see that comes out exactly the same. thing right here. So you might wonder, well, does it matter which way I use? And the answer is, like in this problem, it absolutely would not matter to me which manner you used. Um, to me, one of the most basic things is like just looking at these tables and figuring out, okay, which of these are in my event and circling them and then figuring out what the numbers are. That's pretty straightforward. Um, so if you can do that and you're comfortable with that, that's fine. If you want to use this generalized addition rule or the other addition rule, you can do that as well, right? However, there will be some problems where you will not be able to do it this simpler way, where you will absolutely need um, this rule here. Okay. For instance, if you only knew the probabilities, right, then you're technically using this. You wouldn't be able to count these up and do that. Okay. So you'd have to use that. So there are occasions, it's not like you completely disregard the generalized or specialized addition rule. So, all right, part E was to calculate the probability distribution. So what I would do, right, is just redraw this table, and then I would, do the arithmetic. In this cell, I'd have 129,728 divided by 243,094, and I'd have to do the same thing, right, for every single one of these numbers, divided by 243,094, right, and put that back in the cell. All right, so it's not like it's difficult to do, so I'm just going to leave that to you to do. If you want to take a look, actually the distribution was back here somewhere. The answer was actually one of these that I had right here. So I'm pretty sure that this is exactly the distribution, the probability distribution from that same problem. So should be getting these numbers right here as decimals. Okay. All right, and that is it on this example.